Hello, I'm Donald McIntyre of Nation.com. This is Nation Live, and joining us is David Schwartz, Chief Cryptographer of Ripple Labs. Hello, David. How are you?
Hello, Donald. How are you? I'm good.
Very well, thank you. David, now it's 2015, and after 6 years of Bitcoin existence, there have been many developments, and one of those developments is that some people have found limitations to Ripple, to Bitcoin, I mean, and like scalability and the capability of using smart contracts, connecting nodes. There's several things that people criticize, and there's been an explosion of new blockchains and competing protocols. And I think that sidechains, Ripple, Bitcoin, and Ethereum are the ones that are serious contenders in my humble opinion. So in that context, I read the white paper about the Ripple consensus protocol, and I wanted to talk to you about that a little bit, and then the rest of the network and how it works. But I wanted to ask you, why is it that the Ripple protocol achieves consensus without mining? How is it different?
So it's different in a couple of ways. Mining essentially uses proof of work to solve the double spend problem. That's the problem that you have to be able to send money to two different people, or you don't have a payment system. And if you can send money to both of them, that doesn't work either.
Mm-hmm.
So Bitcoin uses proof of work to solve the double spend problem. Ripple uses essentially a distributed agreement protocol, which essentially means that a group of people just agree on which of two transactions come first. And it turns out that ordering is sufficient to solve the problem. Like if you imagine a double spend in Bitcoin, if we could agree which of those two transactions came first, there would be no question that the second one was invalid.
Yes. Mm-hmm.
And so Ripple uses a distributed agreement protocol just to order transactions. And it turns out that works a lot better than you might think. You might at first think that all of these different servers would have difficulty agreeing, but they prioritize agreement. It's not like different servers have different transactions that they prefer. They just want to agree so that they can have a view that's consistent.
When I read the problems with the Byzantine generals problem in that was written in the 80s, etc., that paper, the main issue was the Sybil attack, where someone would just install many nodes and have majority of voting power. How is that solved with the Ripple consensus protocol?
Right. You have the Byzantine generals problem and the Sybil problem are the two biggest problems that you have to solve to make that work. And the solution to them is a little bit different. So to solve the Byzantine generals problem, what the network does is it looks at what has happened in the past. So you can't agree with certainty on the present, but you can agree with certainty on the past. So to solve the Byzantine generals problem, Ripple servers look at what's happened in the past until they can in fact agree on it, and then they essentially publish the information only after it's confirmed. So if you have what we call a Byzantine failure, where the Byzantine generals problem causes a disagreement, then the network has to go back and repeat the consensus process. But it can do that very, very quickly. If you can do a consensus round, say, every 5 seconds, and the percentage of the time in which you have this disagreement is very small, much less than 1%, then you can still have a very good rate of forward progress on the network. It's not advantageous to try to be perfect if that means being slow, when you can just repeat the process if it fails. As far as the Sybil attack, where someone tries to control the entire network, or someone tries to create thousands and thousands of nodes, the way we solve that is by having nodes have a public key that identifies them as unique. So if I run a node, other people might know my public key. And someone can't create thousands of known public keys because the process by which they become known is moderated by human beings, essentially.
And what is in the case of Bitcoin, the vulnerability in terms of percentage of attackers is 51%. What is that percentage in Ripple?
So if you're just trying to prevent the network from making forward progress, it's lower. You can prevent the network from making forward progress with as little as 20%. But if you do that, you essentially have to cryptographically sign the messages that you're sending that do that, and everybody would just stop listening to your keys. So the the consequence, like if you do a 51% attack on Bitcoin, you make money. You can do double spends. In Ripple, you can only prevent the network from making forward progress. And the solution is very simple. You just stop trusting the public keys that have provably colluded to prevent the network from making forward progress.
That was something that I read, that what you said, the public keys, and in a way there's like identification. In the Bitcoin network, many people say that it's a permissionless network because just new nodes can come in and start participating. Now there's like 7,000 nodes participating normally at any given time. But in Ripple, what you're saying is that each node has to be identified. There has to be like a trust system.
Well, it doesn't cause any difference in your behavior whether other people trust you or not. It doesn't have any consequences for you. So it's not like if you're not trusted, there's things you can't do. You can still introduce transactions, you can still verify them, all of the same things. It's just like mining in Bitcoin. If you don't mine, you can still use the Bitcoin system just fine. You can hold Bitcoins, you can make payments. It doesn't matter to you. As far as a user is concerned, the way you solve the double spend problem is sort of an implementation detail. They just need it to work. The only reason it matters who mines in Bitcoin is because the miners get a mining reward. Yeah. There is no mining reward in Ripple, so there's really no particular reason that you should care how that is implemented. But the nice thing is, though, that you don't need that much agreement. You don't need like if everybody had to trust exactly the same public keys, then you would effectively need a central authority to administer those public keys, which is not what we want. If you just need a reasonable amount of overlap, then you can have any number of people who can publish lists of public keys that they've determined are not likely to collude, and the system will still work just fine.
For example, if I'm an entrepreneur and I wish to be a new node in the system to provide a service, let's not talk specifically about what kind of service. I know see here market maker, gateway, but just any node. Can I just implement it? Go to GitHub, get the software, get a team of developers, implement it, and start being a node, or is there
Yes.
An approval process?
No, you can just fire up a node and everything will work just fine. So what will happen is, if you're an honest person operating an honest node, you don't particularly care like if there's a double spend which way it's resolved, because you're not going to make double spends, and if people make double spends to you, you just need to know whether or not you got paid. You just need to know what you can rely on. So it will work just fine even though you're not actively participating in the consensus process. But then over time, if you demonstrate reliable operation, then other people can start adding your public key, and now you're improving the stability of the network and not just
okay. So it's like a reputation system. It's permissionless in the sense that I can just start participating, but I am going to be trusted more as I behave well.
Right, and the interesting thing is that you can't tell to what extent people trust you. It's completely invisible to you, because when you issue a legitimate transaction, every honest participant is going to try to confirm that transaction. They don't particularly care who sent that transaction or why. So it will appear to work just the same to you whether or not you're actually participating in the helping the stability of the network. So it's just like mining in Bitcoin. You don't have to mine in Bitcoin, and as long as enough honest people are mining, the system will still work. You can mine if you want, and then then assuming you're an honest person who's not going to collude, you're helping to make the system more secure.
This is important because I think that many people have the impression that the Ripple network is closed and centralized, that it's difficult to start participating. But what you're saying is basically anybody can start participating. Over time, it's going to be trusted just by its behavior.
Yes, and that trust doesn't mean there's nothing that you can't do without that trust. It doesn't prevent you from doing anything. You can issue transactions, hold funds, do all the normal stuff. Okay,
you can participate anyway in terms of transactions and checking your balance and things like that.
Yes, exactly.
Very good. So that is I guess that is the base, the database level, the distributed database level is this ledger that we just talked about, and then on top of that. Just like the Bitcoin network has a client, the core Bitcoin core. In the case of Ripple, there are several kinds of clients. Am I correct in saying that there's a software for gateways? Then there's another one for market makers, and then there's another one for Ripple client for the wallet.
Right, and those are all programs that look at what happens on the ledger and introduce transactions. From the standpoint of the network, they're just sources of transactions and things that want information about what happened on the network. But obviously, from the standpoint of the users, those are the way that they interface with the network.
Does that define that there's three types of users on Ripple? gateways, market makers, and end user wallets. Those are the three kinds of businesses I can develop on Ripple.
I think from the standpoint of how they appear to behave on the network, the types of transactions that they do, then right, those would be the types. So you would have gateways or banks or financial institutions that essentially bring fiat currencies like dollars onto and off the network. And then you would have market makers that offer to trade one asset for another and make cross-currency payments work. And then you might just have users that hold their balances directly on the Ripple network. Yeah.
Very good. Okay, so we have the ledger, these three kinds of players, the gateway, the market makers, and the Ripple wallets, which may be just end users. On top of that, what do you see are the applications, the solutions that this brings? Is Ripple geared more to the financial system to move value between financial institutions, or do you see it as something more open for many applications?
I think in the long term it's going to be both, but I think in the shorter term getting financial institutions on board is the best way to grow the system. One of the analogies that I like to use is the way the internet grew. So in the very early days of the internet, it was basically just used by technical people, scientists, and researchers. And it was when big companies like AOL and CompuServe started to provide internet access and started to build this sort of huge infrastructure that it became valuable to everybody. And that's when you saw the next generation of products targeted directly at the internet, like Facebook and Twitter. So I think we're in that infrastructure stage now with Ripple. We're in that stage where we're trying to bring in big players, enterprises, banks, financial institutions, and that will make the platform useful for everyone.
It would be like the first universities in 1991.
Yeah, that's kind of where we are now, and we're trying to move into that stage where we have big players and lots of liquidity, and that way there'll be easy ways to get money in and out. There'll be lots of liquidity for cross-currency and cross-border payments, and it'll become a settlement system that will be of high value.
Very good. The final issue, the final question that I had was Bitcoin. In 2012, Mike Hearn, a core developer of Bitcoin, in one of the conferences, he spoke about smart contracts and smart property and how Bitcoin was envisioned by Satoshi Nakamoto since the beginning to have a space for memory and a script to be able to do things other than the currency, no? Like
right.
manage a property and registries and create third-party contracts like trust and escrow accounts and things like that. The thing is that I think that has failed. Even Nick Szabo, which is the father of smart contracts, said that Bitcoin in a way is too limited for that. So there is a need for something else. Is Ripple as it is limited in the same way for adding programmability, and that is why you created Codius?
I think that's a fair statement. I mean, we could have extended Ripple to include more smart contract capabilities, just like Bitcoin could be extended to include more smart contract capabilities. But then the problem would be, what if you want a smart contract that interacts with both Bitcoin and Ripple, or interacts with Bitcoin, Ripple, and some other system, like things in the real world?
Okay.
It made more sense to develop a new platform, we think.
So does that mean that you started to integrate smart contract capability within Ripple, but then you did it as something independent?
That's exactly right, and that's
okay.
that's what Codius is.
So let's talk about Codius. Codius, what is the purpose of Codius? I read the white paper also. It says it's smart oracle. So it's going to be a node within the Ripple network, or a node independent between networks, that is going to be connected to the real world, absorbing information, and it will also have smart contracts on it.
Right, and the important thing is that it can interact with systems like Bitcoin and Ripple, which means you can have an agent that no one person can control that can manage funds according to rules that are agreeable to a number of people. It's essentially an attested hosting platform so that you can run software in a very secure way so that more than one person can trust that that system will follow the rules that they've agreed on.
So if I am like a sidechain for Bitcoin, or some application on Bitcoin, or some application on Ethereum or Ripple that needs external information, I can go to a Codius node, which is external to all networks and independent, and get that information to execute a contract, for example.
Right, and that contract can hold keys to funds on networks like Bitcoin and Ripple that it will only use in accordance with the software in it. So the problem that you would have today if you wanted to deploy some sort of a smart contract-based service is where does the smart contract run? And everybody
Yes.
has to test that, has to trust that execution environment if the
Yes.
contract is going to handle their funds. So
Hmm.
what Codius gives you is an execution environment that's distributed and secure, and then that becomes the target platform that you can design your application to. So you already know that you're going to get a platform where everybody knows that anything that controls, like funds, will be used only in the way that they've all agreed.
Yeah, I want to clarify that. So the contract can reside on Codius. Doesn't
Right.
have to be on Ethereum, for example.
That's exactly right. And
Or
then
it
the
could be or it could be a contract on Ethereum, just getting information from a Codius node.
right, or it could use Codius so that it could also interact with the systems like Bitcoin and Ripple, or so that it could collect information from the outside world. Exactly.
You use the word host when defining Codius. So does that mean that Codius is not a peer-to-peer network? It's just the independent data centers?
Yeah, it's not really a peer-to-peer network. It is independent hosting, although it does have functionality to allow multiple hosts to cooperate. So you could imagine, let's say you had some very, very sensitive application that's going to hold large amounts of funds, and you don't want to trust any one hosting provider. Maybe you're worried about their physical security. So it does allow you to distribute the
Okay.
application over multiple hosting providers, and then you need some number of them to collude in order to compromise its security.
Yeah. It
And
sounds more like a backup system rather than a network.
it's not just backup because it does provide backup, but it also provides for no single point of failure or single point of compromise for the credentials. And the other benefit of Codius is if you imagine if you tried to do that today and you had to interact with different hosting providers, they would all have their own ways that you provision machines, that you get billing, that all of the sort of mechanics of hosting are implemented. Codius also standardizes those mechanics so that you can add additional hosting providers without having to integrate with different systems.
Very good. From an entrepreneur's standpoint, then, if I want to take advantage of the Ripple network and Codius, I could create a service, say, for example, a banking service or a full service trust service, and I could use Ripple to store value and to move multiple assets, which is one thing that Ripple has, that you can not only has XRP, but you can also move and store many other currencies and assets. And then
Yes.
I could be a host of a Codius node where I provide also the information of external world data and smart contract hosting.
Yeah, you could also use smart contracts yourself to reduce the amount of trust that people have to have in you. One of the problems that people have with trusting third parties is that they're always worried that those third parties will either disappear with the funds or even just stop operating. With Codius, the hosting platform guarantees the security of the funds and it's distributed, so that you don't have to trust a single operator.
Okay, so as a trust service, I can use Ripple as an external platform and Codius as an external platform. But I was saying that I could also be a Codius node as a trustee.
Right. You
Okay,
absolutely could, and I think that's gonna be an interesting business model very soon.
very good. Well, I had the trust versus no trust issue, which we talked about, proof of work, consensus, Internet of Things. What you're saying is in the long term, Ripple is capable of supporting and being a platform for Internet of Things also.
Yeah, I think we will get to a world where not only do we have an Internet of Things, but we can also have an Internet of Things where they manage value. So, like, you could imagine a cell phone paying for its own Wi-Fi access wherever it is, or you could imagine all kinds of applications where the devices that we have can not only communicate with each other, but that they can also buy and sell services as they needed to.
Excellent. Very good. Well, David, thank you very much, and congrats for the good work.
Thank you. It's my pleasure, Donald.
Bye-bye.
Bye.